Hi, we're getting ready to begin programming in JavaScript, and in fact, we're going to jump in with both feet, so you'll need to be prepared for that. I have some examples that I will show you, and I have some things that I want you to do with those examples. You'll have to add some added functionality to them, and you'll have to fix some bugs that I have inserted into the program code just to force you to understand the language more completely. But before we get into looking at these programs that I've written and programs that you will have to actively work through, I want to first of all show you a document that I'll make available in Moodle, and it contains what I think are really essential things that you know almost immediately about programming. So I've tried to distill this down to something that doesn't take a lot of time to read, something that sums everything up very, very succinctly. So when I open this Word document, I have a list of things here that you should read through initially, and I will do just a quick summary of it here before I do the lectures, but you should read through it and think about it. You should watch the lectures. You should come back and read through this again, go back and watch the lectures. The material that we're going to cover is complex. It's going to be different than anything you've seen before, and it is quite doable, but it just is going to take a little time and a little bit of patience. Normally, whenever I teach any introductory programming class, I'll have students pulling their hair out, chewing on their fingernails, and pretty stressed out for a couple of weeks before it begins to click. And in this course, we're having to proceed through the material at a fairly rapid pace, so you're going to have to really put maximum effort into this, and again, be patient with me and be patient with yourself, because this is non-trivial material that we are now getting into. So let me go ahead and just point out a few things in this document here before we jump into the actual program code that I want to show you. And I'll just kind of go through these from the first one to the last one. The first thing I discuss is what an imperative programming language is. Now, if you read about this in Wikipedia or some online source, you can get a further explanation of it. But a imperative programming language, the key thing here is that it's based upon a program algorithm, and the programmer has to think through the solution to the problem and describe step by step how the problem is to be solved. Okay, and most programming languages like JavaScript and C and C++ and Visual Basic, and the list goes on, are examples of imperative programming languages. Declarative programming languages are a little bit different in that you will describe what you want done, and you leave it to the underlying subsystem to figure out how to do it. So you explain what you want done, you leave it to the subsystem to describe how. And if you've taken the CPSC 1100 class, you had a little exposure to SQL, structured query language. Structured query language is an example of a declarative language. Procedural languages are closely related to imperative languages. In fact, they're just kind of an evolution of an imperative language. We still, as we write program code in procedural languages, have to develop an algorithm, a step-by-step outline of the logic required to solve the problem, and then we have to implement the algorithm with program statements, so we have to tell how to do it. But with procedural languages, we can further organize the tasks that need to be performed into programming units called procedures, functions, subroutines, or methods. So depending upon which language we're using, they may be called, any one of these things. And in JavaScript is actually a procedural language, and it uses a organizational unit called a function, and you'll be seeing an example of that right away. Block structure, you will not have to worry about this in the first couple of programs, but we'll be getting into this very quickly when I introduce the if statement before the end of the week. And a block structure just allows us to take logically related statements and group them together so that if one executes, they all execute. Variables are programmer-defined identifiers that allow a programmer to specify where data will be stored as a program is processing it. So a natural thing to do as a program executes is to work with data, transform data in some way, shape, or form. And so it's in order for our program to have access to the data that it needs during program execution, we have to specify variable names. We have to declare variables. And you'll see an actual example of this, and it'll be a little bit more clear to you when we look at a concrete example. But for now, understand that a variable is a descriptive name used in a program. It's defined by the programmer. It's a descriptive name used in a programmer to reference a primary memory storage location. So, if you hear the word variable, think data, storage, primary memory. That's the, the mental picture to put together. Flow of control structures. Imperative programming languages are built on three fundamental flow of control structures: sequence, decision, and iteration. By default, when we develop an algorithm, we will design things so that the solution to the problem is developed step by step, and step 1 will naturally be followed by step 2, which will naturally be followed by step 3, and that order of execution is described as sequential order. That's the default logic structure that's used in imperative programming languages. So, the natural order of things when we write our JavaScript programs will be that statement number 1 executes, followed by statement number 2, and so forth. Now, there are times when we have to veer off from that, and an option that we have available, a second control flow structure that we have available, is one in which there is a true-false test performed at some point, and then, depending upon whether the test evaluates true or whether it evaluates false, we take and execute certain statements. So statements may not get executed at all, or they may get executed based upon the outcome of a true-false test. And when we, get to programs by the end of the first week here, you'll see how that decision logic works, and we'll be using the if statement in order to implement it. Iteration is a third control flow structure that we have available, and under certain circumstances we may want to have certain program statements execute over and over again, a fixed number of times, or while some condition occurs. And in order to make that happen, we use a logical flow of control structure called iteration, or also sometimes called looping. And we'll implement that in JavaScript with the for statement and the while statement. And finally, and I'm going to make life difficult for you because I'm introducing some errors that I'm going to force you to have to deal with. But it is possible to have three basic types of errors in a program. One would be a syntax error, and syntax errors occur when, as you write your JavaScript statements, you don't write them correctly. You misspell a keyword, or you have some kind of punctuation error, maybe leave off a closing parenthesis or something like that. And that causes the language translator, the interpreter in this case, to not be able to translate that source code into the corresponding binary code, the corresponding executable code. So it's a breakdown in translation because the source code statements weren't written correctly. Logic errors occur when you don't develop your algorithm correctly, and when you end up omitting steps, or where you put steps in the wrong sequence and that kind of thing. And then runtime errors are errors that occur when the program does some kind of illegal operation. So if we provide two input values and perform division, the program may work perfectly fine with certain data and blow up with other data. So if we introduce a divisor value that is non-zero, the program will work fine. But since division by zero is an illegal operation, if we somehow at runtime introduce a value of 0 for a divisor, then we'll have a problem, and the program will abort. Now, that's the way it works in a nice, clean environment, but in developing programs in JavaScript that are interpreted rather than compiled, sometimes we will have syntax errors that will lead to logic errors, okay, or syntax errors that will lead to runtime errors. So under those circumstances, this gets kind of messy, but these are the basic errors that you can anticipate. And as I go through some concrete examples, I will refer back to things like syntax, logic, and runtime errors. Okay, so hopefully that quick analysis helps you, and you should read through this several times and keep going back to it, because I'm telling you, very few people can do what we are about to do with minimal attempts and minimal effort. So it's going to require that you work long and hard at this. Okay, I'm going to take a quick break, and when I come back, we're going to take a look at a couple of programs.